Thanks for having me today. So I currently work as a staff engineer at Admiral Insurance, based out of London, and it's one of the largest motor insurance in the UK region. Also, recently I've been onboarded as a GDE in Google Cloud. So today we would discuss about the in and out of Vertex AI and what it has to offer, and how exactly you can leverage the platform whenever you are trying to solve any machine learning use case, or if you are trying out with Gen AI, how can you use the Vertex AI platform? And also, let's say if you want to deploy your machine learning model, or start from cleaning the data and just try out few you know Jupyter notebooks and try out some experiments. In such case, how do you exactly use the Vertex AI? Or I mean, it's a entire tool set, right from cleaning the data to pushing the model and doing an inference out of it. So we'll just start uh, with the agenda. So what exactly we have to cover today? So for the first 40 to 45 minutes, I'll complete my session and then open the floor for QA. Please feel free to ask the questions. So firstly, the overview of Vertex AI and what are the components of it, and how do we implement the end-to-end ML ops and the infrastructure which it powers. So ideally, this would be a very high level session because Vertex AI platform itself is a very huge, and it has its own services underneath. So in such case, there is a lot of time wherein we need to spend to understand each and every service in depth. So I'll introduce Vertex AI and what are the components it has, and we would deep dive into one such component called ML pipelines. So when we talk about Vertex AI, it has a long history. So firstly, Google has launched something called uh, Cloud ML Engine, and then ML Platform, and then they have renamed it to Vertex AI. And currently, there are multiple companies. To name a few, Spotify, for example, uses Vertex AI platform for deploy their models, and there are multiple car manufacturing companies as well who currently use Vertex AI as their core platform for developing and deploying the machine learning models. So it brings us the capability to combine and unify the entire development and the machine learning capability. So what are the features of it? So we have the fast experimentation, accelerated deployment, and simplified model management. So let's say if we consider something way back in 2015 or 2016, so there is a lot of questions on how do we deploy a model. So it was a very early stage of model deployment and democratizing the entire end-to-end model deployment and model predictions. So therein we need to download the Docker and build an image and convert it into the weight file, the train model into a weight file, and get that and do a checkpoint and then upload it. So these were the manual steps previously, where generally the companies used to do it. But now it has changed. Either with any public cloud giant out there, it provides a platform, be it Vertex AI, SageMaker, or Azure AI platform. It all serves the same purpose in a different way, and it all, every platform has its own pros and cons. So yeah, as I said, we have multiple machine learning steps like cleaning the data, pre-process the data, applying the regression models, and evaluate the model and deploy the model. So this is the sequence of the steps which we do in an ideal scenario. However, we would now compare that how exactly we can do with the Vertex AI and Google Cloud. So this is the process, like traditional one, ML deployment and training the model, and continuous training. Let's say if I want to train the model multiple times over each month whenever I get a new data. And then we have model deployment. Model deployment is nothing but if someone wants to use the model which have already been trained, how do I do that? And prediction serving is nothing but, let's say, it's similar to an API, exposing an API to send the data and get the model predictions. So continuous monitoring, how the model is performing, whether my model results are up to the mark or not, and the model management. So right now, many of you might be having exposure to the code, like GitHub and we manage multiple branches of code, multiple versions of it, multiple releases of the code. In the same way, how do we apply that to the model management? So that is something model versioning and model catalog is something which it gets to come into the model management. So ideally, the model development involves data engineering. I mean, we get the data from data engineering team ideally in an organization setup, and then we have data sets. It might be a cloud storage bucket or a blob storage or any other technology for that matter, like a PostgreSQL, MySQL, or BigQuery. And then all the data sets would be read. And this is the traditional steps again, wherein right from the problem definition to the model validation. So this is mainly the experimentation phase. Now, going ahead, we would also relate how each of these service actually works with the models and how we can perform each of these steps in the Vertex AI. And then we have a version control. We have a model registry where we save all the models. This is nothing but compare it with the GitHub where we save the code. And here we have the model registry. So this is the bird eye view of what Vertex AI has to offer. So coming onto the multiple versions of how the models can work, like we have vision models, video. So let's say if we have if we don't have any data but want to apply machine learning on top of it. So for example, if you might have used Google Magic Eraser or Google Photos or Google Lens, so somewhere or the other, it actually works on set of the APIs which Google provides. But let's say if you don't have an expertise to build the models, but you want to train few models with the data you have, in such case we use no code, low code workflows, wherein we have AutoML provision to train the vision models. So let's say I want to train an object detection model, or I want to train a uh, video captioning model or language model. In such case, I can use the Vertex AI AutoML. And let's say if I am in the experimentation phase to build the model with the data I have, I can use the Vertex AI Workbench, which is nothing but a Jupyter notebook instance, which is created by the user to use on top of it, and then release the developed models right from there. And then we have few integration services. For every model, we understand we need data. So data should be reside in some or the other part. So we have cloud storage, BigQuery, Spark, Spanner, and BI. So these are the integration data services. Few of them are the particular engines to run the code, and the other are just the storage area where we can store the data and read it. So let's say if I want to explore more and train the model. So after experimentation, let's say I have developed the code. Now I want to train the model. So in the training phase, I would just use custom workflow and train the model. So in the training as well, we'll also see that in depth in the upcoming slides. And then once we develop the model, the next step is to deploy the model. So the model can be deployed in multiple ways, in multiple steps. So one such step is model prediction. It's a again the service which it offers on the fly in the Vertex AI. And at last we have MLOps. So we might know that how the code is managed and how that code pipeline is managed, for example using um, GitHub pipelines or Azure DevOps pipelines. In the same way, when it comes to the uh, machine learning, we actually term it as MLOps, and this consists of how do we manage each version of it and how do we promote each model from dev, test, and production. So for that we have model monitoring, explainable AI, and these comes after once the model is deployed and want to understand how the model is performing. Of course this should be set up while the development itself, and we have a pipelines which covers all these steps. So firstly, we would discuss about each component at a very high level and what is the use of it, and then we would dive into the MLOps pipelines. So firstly, we have managed datasets. Managed datasets is nothing but whenever we want to apply the AutoML model, we want certain data, right? So let's say if I have data, I want to train a model, but I don't know how to write the code. In such case, I can create I mean, what task I am trying to solve. Let's say image classification, image object detection, or segmentation. I would create a data set with the corresponding type and then submit it to the AutoML. So in such case, the AutoML would read the data from these particular data sets and then train on top of it. So in the similar way, I have it for tabular text. Text is nothing but text classification, text entity extraction, text sentiment analysis. So this actually provides a way to train our models without expertise. And I mean, this is something called AutoML. But right now we have multiple ways to get these via new age LLMs and the other multimodal models. And then we move on to the Vertex AI Workbench. So Vertex AI Workbench is not, it's a kind of Jupyter notebook, but it has many features compared to that. So how it works is, let's say if I have, if I want to write the code, generally 80% of the cases, let's say we use, I mean, at least I use Python. So in that case, I can spin up a workbench on the Google Cloud and write my Python code in the form of Jupyter Notebook or Python files. So how exactly it is different? So let's say you want to run a very big model and submit a job. In such case, I can directly create a notebook here and submit the job onto the GCP. And how exactly it integrates? So let's say if I do it on my local machine in my own laptop, how it works is I need to create a service account and then connect it with the uh, remote server like BigQuery, and then get the data and then perform all the operations. But in the case of Vertex AI Workbench, as it is already on the Google Cloud closed network, and it I mean the network for the Workbench is private to itself. In such case, there is no external connectivity or the data movement happening to the public channel when we actually develop on Workbench. So that's one of the key use of it using Workbench. But apart from that, we can use PySpark, TensorFlow, and R language. Also, many other tools like PyTorch whenever we want to develop our models. And one best thing is all the required packages are pre-built. So let's say if I want to work with GPUs, I can also turn up GPUs. And recently, some new features also released to use the TPUs as well whenever we want to run some memory intensive workloads. So then we have a feature store. So if you any one of you have worked on machine learning, you might be knowing about features. Features are nothing but the enriched version of the columns which we are tend to use to train the models. So let's say if you actually lead 10 teams and 10 teams have to develop machine learning models, in such case you might need multiple features. I mean, let's say if team 1 uses features A to Z and team 2 also uses features A to, let's say, A to Z, and then team 3 also uses team only features PQR. So now each team is using different features, but everything comes under A to Z itself in a hypothetical case. In such case, you can actually create a feature store which would be universal to all the teams, and each and every team can use features from that particular single repository. So that's something which we call as feature store. So that is something which we can create on Google Cloud to enhance the reusability of the end-to-end feature store features. And this also increases, let's say if the data changes, if the underlying data changes, now the features should also change. So that management would also be possible when we actually use Vertex AI feature store. I mean, there are multiple feature stores out there, but Vertex AI provides its inbuilt out of the box feature store where we can save all the columns which we need to train the data uh, with our models. And let's say once we have data, once we have columns, then the next step is to do training, right? So as part of training, what happens is we have multiple ways to train our model. So in the earlier days, we used to do it on laptop or a Kubernetes server on any cloud or a compute engine. I was talking way back in 2015 or 2016. So after that, we got a lot of maturity in the model training and the platforms out there. So currently, if you see, I mean, most of you might be using ChatGPT or any similar generative AI tool. So how do they actually train the model? Like they have around billions and trillions of parameters to train on. So how exactly it works? So they actually train it on GPUs. It's a kind of NVIDIA H100 type of GPUs is what I read last time. And you might also heard about Google Gemini, uh, Gen AI API or Duet AI or BARD, which is again a generative AI tool. How exactly the models of this particular LLMs have been trained? So those models have again trained on NVIDIA, and particularly Gemini model is trained on the Google TPUs, tensor processing unit. So there is a lot of hundreds or thousands of GPUs and TPUs behind training the models. So let's assume you also want to build something very, very scalable and a robust or complex model. You need a lot of memory and the infrastructure to train the model, right? In such case, how exactly you can do that? Let's say if I do my laptop is only of 16 GB of memory. How can I scale that? So that is something which you can do with Vertex AI. You can select the amount of memory and the RAM and the number of nodes you need, and then directly you can train the model by submitting the code and the data. You are consuming the infrastructure which the Google Cloud provides. And then we come to the model registry. So model registry is nothing but, let's say now the training is completed, right? Now the next step is to understand and track the model and make the versions of it. So let's say how model versioning works is, I have a type of model, let's say model X. In that model X, I need to maintain multiple versions. So let's say my data would uh, refresh once in every week. Now after every week, if I don't refresh the model predictions might be uh, skewed. I mean, the model predictions accuracy might go down, let's assume. So now, for sure, I need to refresh the model every week. In order to refresh, I need to retrain the model, be it from the scratch or be it from the checkpoint where it has last been trained. In order to do this, I need to keep track of the versions. So let's say after 6 months, if you want to retrain the model again, if you want to retrain uh, or get the model version 1, how do you have a rollback option? So in the production, when you deploy the model, if something goes wrong, you just roll back or you apply fallback mechanisms. So in the same way, we have a few things here in the model registry. So it registers, organizes, and tracks. So that's something which we discussed, and it stores the model metadata. So model metadata is nothing but, it actually handles all the dependencies, and when I want to deploy the model, what are the required key metadata which I need. And it also maintain documentation, evaluation, and govern the model launch process. So who approves the model? So when we I mean, when we generally work with code, let's say if I work on the development branch and I create a pull request to merge with main branch, that's the general tendency. In order to approve the code to the main branch, that is, someone needs to require to approve it. Let's say if that is approved, then only it would merge with main. So similarly in the model launch process as well, if I want to push the model from QA and production, it needs to go through some review, approve, and release process. So in such process can be also governed using a model registry. And which particular tool or segment is beneficial for you? So this is the flow graph wherein we can make a decision. So do we have our own training data to run the model? Let's say if we don't have it, we generally go with the pre-trained APIs. So this is something which works in the similar lines of just using an API, or let's assume it's similar to using Google Lens app or Google Translate app. So we just use the APIs to send our translation text. Let's assume if you want to translate something from English to Arabic, I'll just use this pre-trained model and directly send my translation text in English, and it gives the response in Arabic. So it's similar to Google Translate. Let's say if I have my own data, but I cannot write the machine learning code, then I go with the AutoML. And let's say if I have my data and I have the expertise to implement and develop the model, I can go with custom model tooling. So now the next step is to have the robust and reliable model hosting. So now we have the model trained, we have a model registry, and the next step is to deploy the model such that I'll get all the predictions. So Vertex AI provides a model registry as well, which we discussed, and it would also provide a endpoint service. So now I have a model, I need to expose so that it can be consumed by someone. So it's similar to as an API. Let's say in the REST API, I would call that API with some payload and it gives me a response. In a similar way, Vertex AI endpoints is nothing but uh, for every model in the model registry, if we want to expose that to the external world or publicly, I would uh, create an endpoint and use the corresponding model and then expose it. So every model comes with an endpoint. Endpoint is nothing but a kind of REST API, and then a model endpoint ID and how many models are there currently running. And you can also configure your endpoint machine. Let's say if I want to do an inference on 16 GB server or 32 GB server, that is also possible using this particular Vertex AI endpoints. So we can also split the traffic between different models. So let's say uh, based on IP, we can migrate the traffic. Let's say if the traffic coming from uh, a different country should go to a different model, and in such way we can do that. And we can also customize the endpoint machine types, like let's say based on the load. Let's every day at 8 a.m. my load is high. At that point in time I can increase the machine types to 128 GB instead of 32, and then reduce it based on that. So that is something which is also possible with Vertex AI endpoints. So then comes the machine learning pipelines. So till now what we have discussed is how do we get the data and how do we create a feature store and what is the importance of that. And the next step is to experiment. That's something which we can do in workbench. And the third is to train the model. Let's say I completed my development and then I want to productionize it and train it. So that is when we use Vertex model training. And then once we train the model, we need to keep track of all the versions. So for that, we have model registry. And once we get the model registry, I want to deploy it. And in order to do deployment, so when we build the model, it's of course to be consumed by the external users. So in such case, we build the model and then uh, deploy it. For that deployment, we have Vertex A endpoints and prediction. So now let's say this we want to automate this entire cycle, right from data collection, sorry, right from data collection to the model and till the deployment and the endpoint. If I want to actually automate the entire process, how do I do that? So there comes the ML ops, which we have seen in the diagram earlier. So oftentimes in the organizations, the expectations are clear, but the reality is something which is very tangled. So how do I overcome this? So for that, we have multiple tools out there in the open source market and by the other public cloud players. But here we would discuss about Vertex AI pipelines, and also at the end we would also discuss about some part of generative AI. So generally, what happens is we would discover and experiment and then train the model and then serve and connect. So this is both for predictive and generative AI. So how exactly we can manage and govern? As discussed, we have feature store, metadata store, and model registry, model evaluation. So these are the four steps we need to take into consideration whenever we want to automate the end-to-end pipeline. So how exactly a Vertex pipeline looks? So in the traditional way, in the diagram from the first slide where we have seen, we need to maintain multiple files for multiple different steps like load data, evaluate model, train model, deploy model. These are the multiple files which we have seen in the initial slide, right? So now how do I overcome that? So we have a get data. So this task gets the data from any data source like BigQuery or Google Cloud Storage. Then we have something called dataset train. So this is an object. Object is nothing but a file here. And then I am training the model. Whenever I train the model, the output would be a model artifact. And then I would evaluate that model using the test data, right? How the output of get data is both test data and train data. So after evaluation of the model, I would have metrics. So I mean, this is again a very interesting topic and also important whenever we develop or try to automate end-to-end pipelines. So I mean, in order to deep dive, we might need multiple hours to do so, but I'll just uh, guide you how exactly you can go through it with some references at the end. So we can have a batch pipelines and it's fully serverless. That means I can just write code and deploy it. This doesn't require any servers or any other workloads which you need to create and pay for it all the time throughout the day whenever you don't need as well. So we can add conditions and track artifacts lineage. So this is basically built on top of Kubeflow. So Kubeflow is a open source platform similar to MLflow. So whatever we see here, this the underhood technology is Kubeflow. So how exactly the orchestration works? Let's assume these are the steps in my entire model creation, right? So data exploration, data set, nothing but feature store, training, evaluation, selection of the right model based upon the metrics, and deployment and monitoring. In this entire cycle, we want to repeat it based upon the data refresh rate or on-demand ML model training. So in order to perform or implement these steps, we are having each and every tool in the Google Cloud. So firstly, data exploration. For that, we have um, multiple tools like data prep. Um, I mean, if that is required, and then we have BigQuery and to perform some EDA, in-house EDA, and data set for training, we have custom training, AutoML, and model training and BQML. And then we have model registry, and as part of evaluation, we can directly do that at the end of model training as well, comparison, deployment, and monitoring. So now these are the steps which we need to do end to end. But let's say if we don't implement or automate it, every time we want to do it manually. So there is no other way to perform it, right? So how exactly we can stitch them together and run them automatically whenever we need it. So simplifying the entire process is something which we get out of uh, MLOps when we implement. So the MLOps is more like an automation for ML models and operationalization of it. So these steps, so let's say data is saved in BigQuery. That would be the first step, and validation of data. So that would be the second step in Vertex AI training, and processing data proc. And let's say if the entire model is trained, I want to deploy the model, Vertex AI prediction and endpoints, and I want to save the results and metrics and metadata. Then we have artifact store. So each step in the Vertex pipeline is a Docker container. So if I have a model written in TensorFlow, in Vertex Workbench, I would actually write the model, experiment it, and create a Docker out of it and push it to the container registry, and then use it in the Vertex pipelines. So this is the end-to-end pipeline, and I'll just show you the example of how exactly we formalize the pipeline. So how exactly and easily we have to use it. So someone who knows Python uh, can easily use it by using Kubeflow Pipelines SDK or TFX. So we can build pipelines in two ways: TFX extended, which is TensorFlow extended, or Kubeflow pipelines. And how about scalability? It's again serverless and cost effective. Cost effective in the terms, so I guess each pipeline takes around 0.03 US dollars for each run of a end-to-end pipeline. Of course, the underlying resources which we use, for example, we are using Vertex AI training. So training uses a different cost in itself, but each pipeline run from the starting step to the last step would incur us $0.03. And let's say in that process, I'm training the model, so that training service would cost separately. So security, we can have the customer managed encryption keys and IAM roles attached to it, metadata tracking, because each and every step has the metadata to it and the artifacts with the model lineage, and portable. So let's say if I don't want to run on Vertex pipelines, as I already said, the underhood technology is Kubeflow. We can anytime move them out and run it on top of the Kubeflow as well. So how this particular pipeline looks. So here we have a BigQuery create model job. So this is nothing but it actually uses this task. So the image here, which is I'm highlighting, is nothing but a Docker. So this is the step in which the model is trained, and the model explanation. So this is evaluate model, and this is to explain the model. And the next step is to plot the evaluation metrics. And let's say in a case wherein if I don't want to proceed to push the model into production, if my accuracy is less than 70%, how do I check that? Or let's say here in this example, they are checking 95%. So whenever my accuracy of the model doesn't reach more than 95%, ignore that model. If it reaches more than 95%, then only create an endpoint, or else notify the users that the accuracy is low. So that threshold or conditioning can also be done here. So this is endpoint creation. Endpoint creation is nothing but exposing the model as a REST API to be used and uploading the model as endpoint. So this is the generic and straightforward model pipeline example. And every pipeline example, I mean, every pipeline has multiple steps in it. So a few of them are like writing your pipeline code in KFP. KFP is, I think, Kubeflow pipelines DSL, and then compile pipeline and submit the pipeline to Vertex AI. It parses and then runs the pipeline. And then once you complete these steps, you can see something like this. So these are the components. I will just touch at a very high level. So component, wherein I would create an input where the input is coming from, the core logic, and where I need to dump the output. So in the same way, we have Python DSL. So here I'm just writing the entire code. So this part is the code wherein I write my training job. Let's say if you already write this in the workbench and then push it here and then want to uh, automate the entire process, you can do as part of the pipeline. So now the next step is to compile. After compilation, we get a JSON file which actually has all the specifications of the entire pipeline. So this is the end-to-end process: uh, ingestion, analysis, and then we have uh, then we have the training, MLOps, evaluation. So this is the process where we follow uh, in the traditional machine learning process. So till now we have discussed about predictive analytics and um, how exactly we approach machine learning problems. But right now we would think of, I mean, the buzzword is Gen AI. So just giving a glance on how exactly we can use Gen AI on the Vertex AI. So right till now, just to summarize, we have seen right from ingestion to the deployment, what are the services we have in Vertex AI and how do you can use it. Uh, Starting from uh, data ingestion, BigQuery, Google Cloud Storage, or you can create a managed data set on Vertex AI. For training, you can use AutoML or custom training or BigQuery ML. For the feature store, you can use Vertex Feature Store. And in order to optimize the models and validate and evaluating the models, you can again use the custom containers or Vertex Visor. And once you have all the model ready, then you can push it to model registry and maintain the versions there. Once you satisfy with the results of that particular model, then you can push it to the Vertex uh, endpoints predictions. Once we get the REST API, and uh, then I can directly call that API for the inference. Now, in order to automate all this process, I can implement a MLOps pipeline. So each, if you go by by component, it's pretty much straightforward. And then now we move ahead into Gen AI with Vertex AI and what it have to provide. So Vertex AI has Doc AI, Contact Center AI, Translation Hub, and Risk Analysis AI. So document AI is nothing but parsing the documents. Contact center AI is, I mean, it's much more intelligent than that. Contact center AI is something wherein uh, we want to automate the call center I mean, call centers. So let's say if uh, with the general with the traditional IVR, in such case we use contact center AI. So this is something which is interesting, model garden. So we all know that we have OpenAI models and uh, Facebook and or Meta models and Google Foundation models, Hugging Face models. So this is the platform where it has all the Google developed models and open source models and also the partner models. So let's say if I want to use a stable diffusion model by Hugging Face to develop my LLM, or to tweak it and fine tune it and develop on top of it, then I can pick that from Model Garden and uh, tune it or distill that model. And then uh, in order to implement all the generative AI projects or some POCs, we have generative AI studio for that, and we have data connectors as well. So the main differentiator, this again comes under Vertex AI's model garden, where we can have the access to all the services. As I already mentioned earlier, we have Google Cloud Infrastructure TPU as well. So this is the Vertex AI Gen AI side of it. And then we have how exactly we can implement using Gen AI within. Firstly, we can pick the models from the model garden, task specific or open source or foundational models. Then we can use the generative AI studio in order to fine tune or distill the model, and then design some prompts on top of it, and train that model based to the use case, specific use case. So this is how the modern model garden looks like, wherein we have all the foundation models and all the models based upon its category, like language model, vision model, video, embeddings, extraction. And then this is a generative AI studio wherein I can design my prompts and fine tune the model and make the LLM understand these are kind of prompts it might get in the future when it would be released. So let's say if I want to if you want to tune your own model on top of a foundation model, you can do that in the generative AI studio. And here are the pre-trained models which we have: vision, language, conversation. This is again a traditional Vertex AI, not the Gen AI side of it. And this is something which we discussed today, right from getting the data engineering, data ingestion, preparation, storage, model development, ML engineering, and insights. And this can be across multiple users, right from data engineers, ML engineers, and this is something which is Google's data cloud, right from to handle all the use cases across the board. And this is something which I have today. And now I open the floor for questions.